Welcome back everyone. My name is Sagar and we are back here with another video. So today is day 182 of our POTD series and today's this question name is find minimum number of laptop required and this is given a medium level question. So we will treat it as a medium level question and the statement is there are n jobs and the start and finish time of job are given in array. So there are two arrays given that is start array and end array and they are of size n and each job require one laptop and laptops can be shared. So that means if we are doing one job from this start time to this end time, then we need one laptop, and we cannot share laptop while doing multiple jobs. And we have to find the minimum number of laptops required, given that you can give your laptop to someone else when you are not doing your job. So that means there are n jobs there, right? So maximum number of laptop required can be n, but we have to find the minimum number of laptops that we need to do all the jobs. So that means if we are starting a job and then we end it, so then we can after ending then we can use this laptop for doing some another job. For suppose for this example, so our first job is from 1, so this is 1. So if we are using a number line, so suppose this is a timeline, so this is 4, and then this is 1 to 4, and here it is 2, and here it is 3, and after that there is 3 to 6. So suppose there is this 6 and there is 5. So suppose we are starting off our first job from 1. So we started using one laptop, our first number of laptop from this point, and we have to use this first laptop from 1 to 4. So this first job ends at 4. And about second job, so second job start at 2. So we know that we are using one laptop, our first laptop from 1 to 4. So we cannot just use the same laptop because it's ending its job at point 4. So when we are starting another job at 2, so we have to use another laptop. So we have to use here our second laptop. So number of laptops are here 2. And after that we have to end this second job at point 4. So that means if we are ending at point 4, that means if there is some another job that is starting at 4, so we can use any of the laptop from this. So but there is no job that is starting at 4. Another job is starting at 3. So our third job is starting at interval 3, and that means we cannot use this laptop because it is ending its job at point 4, and we also cannot use this laptop because it is also ending its job at 4. So that means we have to use our third laptop here. So this is our third laptop and that is ending its job at 6. So there are total of, you can see one laptop that is doing its job from 1 to 4, and then second is 2 to 4, and then third is 3 to 6. So there are total of 3 laptops that we have to use to complete all of the jobs. And if we are using this second example, so suppose in this second example, so first of all we will create a timeline from 1 to, there are maximum of 6. So 6, 5, 4, 3, 2, and 1. So we are starting our one job from 1 to 2. So this is our first laptop timeline. So our first laptop will start working from this point and end up to this point. So this is our first laptop. And about our second laptop, so we don't know either we have to use different laptop for this 5 to 6 or from this 2 to 3. So what we will do first, we will sort this array according to our increasing time, according to our starting time, or we will just see if either we can also sort it according to our end time or not. So first we will see how when we are starting our work. So we have to sort this array according to our starting time. So our second job is starting at 2. So as I said, we can use this laptop to start this work because we are just ending our work at interval 2. So we can just start doing another job at interval 2. So we will just use this same laptop to start our second job. So our second job will start from here. So we can just see 2 to 3. So we are doing another job from starting point 2 to ending point 3. So we are just doing another job and this is using only one laptop. First we are doing our work from 1 to 2 and then 2 to 3. So this is using one laptop and then third job is at 5 to 6. So this is our third job, 5 to 6. So we can just use the same laptop. This laptop is empty from 3 to 5 and we can just use it from 5 to 6. So that means we can just use only one laptop to do all the three jobs. So the answer will be 1 as you can see. So I hope now you got this question, but how can we solve it? So first of all, we saw the first approach that this is our first thing that we have to do. We have to sort according to our starting time. because the starting time is the time that we need to tell when we have to start our another job. And if some laptop is free, as you can see here, this first laptop is free when we have to start our second job. So we can just use, so we have to sort according to our starting time so that we can see either any previous laptop is free or not. And if any previous laptop is free, then we can just use the previous laptop. And if it is not, then we can just create or we can just buy a new laptop to do that work. So we have to sort according to our starting time, and I hope now you know the reason, because we have to check for previous laptop when we are starting something. So after that, what is our second task to do? So first of all, let us just sort this array according to our increasing time. So we will just create. So if we are sorting just directly this array, then this will shuffle the starting time according to end time, and we don't have to do that. So we have to manage this thing. So we can either use a map for this, or if we have some repeating values, then we cannot use a map. So we will just create a 2D array that have this 1 to 2, 1 to 2, and then so this is the simplest method that we can do. We can just create an array of size a complete array of size n which have element as an array. So another element is 5 to 6, and the third value is 2 to 3, 2 to 3, and then we can sort them according to their starting value, that is zeroth value. So if we are sorting them according to their zeroth value, then 2 3 will be here and 5 6 will be at the end. 2 3 and 5 6. So that is our sorted array. So first of all, we will just do this step, and I hope now you know why is that, what is the reason. Because if we are just sorting our starting time, then this will be sorted, but the end time corresponding to their starting time will not match each other. So first of all, we will create this 2D array. We'll name it ARR, and the size will be n into 2. Size will be n into 2 because we can see here one element in our array is of two size. So we will just create n into 2 size, and we will iterate in our starting and end time. I should be less than n, and our ith element in our array will be a new array that will contain two elements, that is starting time of ith value and ending time of ith value. So that this is what we are creating, but it is in sorted order. So we also have to sort this array. So how can we sort? So we will use just a custom comparator. So we know this method arrays dot sort, and we have to pass here our array. But here if we are using this and we want to sort our array in some custom value though, so then we can use our custom comparator, and we will just use their a lambda value. So if you don't know about this, don't worry. We will just do this thing in our Java plus DSA course. That course is also completely in English, so you can just check that out. And that Java course will be continuing very soon. And after doing our oops, then we will just see this what is this comparator class and how can we sort our array using this custom comparator. So what we will do, if their initial value is not equal to each other. So if there's zeroth value, that means their starting value. So this zeroth value is their starting value. So if their starting value is not equal to each other, then we will sort according to them. So A0 minus B0. So that means first this will be 1, this will be 2, and this will be 5, and they will also sort according to their corresponding end time. And if they have equal starting time, so suppose there is some job that have equal starting time. So suppose this is some job that will start from here and will go up to here, and there is some another job that is also starting from here and will go up to 5. So that means we have to sort according to their end time now. So if they have equal starting time, then we will sort according to their end time, that is on first index minus b1. So a0 minus a0 minus b0, that means we are sorting according to their starting time, and this is in increasing order, and this is also in increasing order when we are sorting according to their end time. So first this will be sorted. So now this array will be sorted in increasing order, and after that what we have to do, so our second task will be, so first we have to check. So suppose this is now our timeline, so 1 to 6. So we will just use the previous one. Let me clear it. So this is now our timeline, and what we have to do. So first of all, we will just see our first example. So this is our example. and we will also sort that array according to its starting time. So 1 4, 2 4, and 3 6. This is already sorted. And what we will do first, we will check 1 2 4. So we are doing our first job, and then what we have to do first, we have to check either the starting time of our next job. So this is our next job. So 1 to 4 is our first job. So we have 1 to 4, then 2 to 4, and then, so let me write it clear, and then 3 to 6. So we have three jobs there, and we are writing our first job. So at least we need one laptop to do our job. So that is obvious. And we can see n value is greater than equal to 1. So that's obvious. Our minimum value will be equal to 1. So we will start our answer with 1 and answer equal to 1. And what we will do first, we need this job. So first, obviously, we have to do our first job. So we will just do our first job from start time to end time. But after that, after this point, we will check for this job. What we have to check, either the end time of our previous job is smaller than or equal to our starting time of this job. So if that is the case, so not only the previous job, but we have to check all the previous job which have laptops to working on. So what does that mean? So let me just give you some example. So suppose there is some job 1 to 2, 1 to 3. Let us take 1 to 3. 1 to 3, then 1 to 4, then 2 to suppose 5. So and after that we have 3 to 1. So suppose this is our example, and yeah. So suppose this is our example, and we are here. So we are checking for this job. Either previous jobs have any laptop which is free, which have time of end time less than or equal to 3. So that means we have to check all the previous job, but that will just take our time and square. So because we are checking all the jobs, but we don't have to necessarily check all the jobs, because all jobs don't have any laptop that they are working on. Because suppose for this example, so if this is 3, and let us just take this 2. So this is 2 to 4, and this is here 2. So if we are checking this job, so when we are checking for 3, so that means there should be any previous job which is ending at 3 or less than 3. So if we are checking for this job, so we have to check first this job. So starting time of this job is 5, and that will end at 5. So starting time is 2 and ending time is 5. So that job is not ending at time less than or equal to 3. So we will check another job. So when we are checking this job, starting time is 2, ending time is 4. So that is obviously greater than this start time. So we cannot use this laptop. And when we are checking this laptop, so starting time is 1 and ending time is 2. So we know we can use this laptop, but this laptop is already being used by this job. So that means we cannot just use this laptop. So we cannot just use this basic approach, brute force approach, to check all the laptops that are previously used. So what can we do now? So first of all, we need to have a sort of data structure to store all the free laptops that will be free at some particular time. So what can we do now? So for this example, suppose this is our 1 to 4. So that means this is our first laptop that will be free at a time interval 4. So we will just store this 4. And when we are here, when we are checking for our second job, then we don't need to check our previous job. Then we will just check either this laptop, the minimum free time of any laptop is less than or equal to 2 or not. So we will just store. So how we are storing? So first of all, we are storing 4, because this first laptop is going to be free at 4. So we will just store them that the laptop that is going to be free is at 4 interval. So we will just check the start time. So start time is 2, and the minimum time for any laptop to be free is at 4. So this is 2, this is 4. So there is no laptop that is free at time interval less than or equal to 2. So we have to use another laptop. So we will use here another laptop that is from 2 to 4. So we are just using our second laptop, and that is also becoming free at 4. So we will just use there another 4. That means now there are two laptops that will be free at time interval 4. So we just have to remember that thing, and we have to store that thing in our sorting order, because we will just check from our starting point that the minimum time of any laptop to be free is less than or equal to our starting time or not. So after that, after our second job, we will check our third job. So the starting time of our third job is 3. So we will check either the minimum time of any laptop to be free or not. So the minimum time of any laptop to be free is 4, and we have to start a job at 3. So that means we cannot use any previous laptop. So we will just create another laptop. 3 to 6. So that is there are total 3 laptops, and suppose we are extending this example. So suppose there are more jobs here. So there are four. So two laptops are there that will be free at 4, and there is also third laptop that will be free at 6. So another laptop will be free at 6, and after this 3, then we have to use 4 to 5, and they are 5, and they are 4 to 7, and they are 7 to suppose 9. So suppose there are 3 more jobs. So now we are checking this job. So starting time of this work is 4. So we will check either the minimum time of any previous laptop to end its job is 4. So we can see the starting time of this job is 4, and the previous laptop is also ending its work at 4. So the minimum time is this. So we have to sort that in increasing order so that we will always check our minimum time. So either we can also sort this, or we know how can we get our minimum value. So we know that getting minimum value is either by priority queue or by sorting. So instead of sorting this value every time, this dynamic array every time, we will just use a priority queue here. So we will just get the minimum value, that what is the minimum time for any laptop to be free. So this is 4. That means any previous laptop is ending its job at 4, and we have to start another job at 4. So that means we can use this job to for a previous laptop with the previous laptop. So we will just start this job at 4, and we will end it at 5. So that's how we are gonna work. So we will just use a priority queue here, and after that this is our second job. So we know that this job is ending at 4. So we also have to add it here. So 4, 5, 6. So this 4 is for this second laptop, right? And after that again we will just get this 4. So starting time of another job is 4, and ending time of any previous job is also 4. So we can just use the previous laptop, and we know we can use this laptop. So 4 to 7. 4 to 7 it is. So there is 7, and after that there is another job. So we will just remove this 4, and this is ending at 7. So we also have to add here 7. So 5, 6, 7. So there are just 3 laptops that are ending its job at 5, 6, 7. So 5, 6, 7. So we are just using only 3 laptops up to here. And after that we have to check for next job. So next job is starting at 7. So what is the minimum time of previous job to end? So that is 5. So that means we can use this laptop to work at 7. So to start our work at 7. So we will just use this laptop to start our work at 7, and we will end up to 9. So that means there are only 3 laptops to do all these 6 jobs. So I hope now you got this, how we are storing the end time and how we are every time calculating the minimum end time to do our work. So we'll just use here a priority queue of integer. And if you still didn't get this, so let me just write here algorithm, and then we will try run for this. So priority queue. So there was just a demand for English videos, and that's why in this video we are trying to solve this problem much in English. So first of all, we have to add this one. So first of all, we have to do our first job. So that's why we are starting our answer at 1, because there is minimum laptop required is 1. So what we will do? So we have to start checking from our second job, because we already have to do our first job, and that will be ending at end point of this first job. So first of all, we have to add some value to our priority queue. So priority queue, and let me just write it again. So our jobs are 1 to 4, 1 to 4, and then 2 to 4, and then 3 to 6, I think. 3 to 6, and suppose there is also another job that is starting at 4 to 5. So this will use this laptop, okay? And we are using here a timeline. So I think that is the simplest method I can easily teach you for this question, and I don't like the solution that is given in that editorial. So you can just refer to this solution. The time complexity and space complexity is exactly same, because here we are using O of n space for this array and O of n space for this priority queue, and the time complexity is n log n for this sorting, and also n log n for this priority queue. So first we are starting our job at 1 and ending it at 4. So this is our first job from 1 to 4. So we have to add that to our priority queue, that the minimum time of our first laptop to be free is at 4. So we have to add that to our priority queue. That arrays zeroth value and time. So one means end time, and that is our first job. So that means 4 is the end time of our first laptop, and the answer is 1. You can see, and we have to check for all the other laptops, that is I equal to 1, I should be less than n. So first of all, we will get the start time of our another laptop, that is arrays ith value 0. Yani ki that means 0 means our starting time, and arrays ith value 1. 1 means end time. So we just get this starting time and this ending time. And what we have to do, we have to check for our starting time, that the minimum time to end our previous job is less than or equal to our starting time of current job or not. So remember that word, that we have to check. We don't have to directly remove this from our priority queue. So we have to check, right? So the minimum time is currently 4, and we have to check pq dot peak. So if the ending time of any previous job is lesser than or equal to our current job starting time. So current job is starting at interval 2. So that means the current job is starting at here, and the previous laptop is stopping at point 4. So we just cannot use the previous laptop. So we have to create here another laptop for using this job, for doing this job, right? So that will be 2 to 4. Okay, so that means we just have to check if the previous job is ending at a time less than or equal to starting. So if our starting time is later than previous end, so that means we can just use this previous laptop for this job. And that means we can just use this previous laptop. That means we will just remove this. So previous time will be removed, and we have to add a new end time now. So when we have to use new end time, so that means we are removing our previous time. So that means now this for this example, so this time is greater than our starting time. So that means we just cannot use this previous laptop. So that means we have to use here another laptop. So to use here another laptop, so that means we are here in else case. So here pq dot peak, that is 4 is greater than 2, right? So we just cannot use the previous laptop, so we will not enter here, and else we have to increase our answer. So that means we have to use here another laptop, and every time we have to also insert the starting time. So that is we have to also insert here end time. We also have to insert every time the end time. So every time we will just add end time, and we also have to increase the I. So that is the whole algorithm that we are working here. So that means we will check this for, is this the end time of our previous job is less than our starting time? No, it is not. So what we will do, we will just use there another laptop, that means the second laptop. So else, that means we are increasing our answer, and every time either we are using previous laptop or we are using new laptop. That means every time we have to add the end time of our current job. So that is how our algorithm work, and at last we have to return our answer. So I think the video is long enough. And the time and space complexity is the same. N log n is time complexity, and space complexity is O of n. So that is all about this algorithm, and I hope now you understand this. We have to just check the minimum time of previous laptops to end their work, and if the previous laptop is ending the work at here, then we can just use it from here. So we can just start using our previous laptop, and we can just add end time of our current job here. So that is how our algorithm works. And let me know if we have to make more videos in English, and you will just get this solution in our DS repository. So I have to write here also, use priority queue to check and minimum end time, right? Minimum and time of previous laptop to be free. And then we have to compare that with start time of our new job. Start time of our new job. And we can just now copy this whole thing and paste it in our DS repository. Copy, and you can also copy the question name. So you can just check this DS repository and start this so that you won't miss this. and you can also contribute this, like there are also a lot of contributors. So if you have any different approach for the solution for this question, then you can just add here this GFG. Okay, I am adding, so you can just append your approach here. So I have to paste this solution, and you can just append your solution after this one. So you can just add a comment, my solution, and then you can just paste your solution here, and you can just create a pull request. So I will just accept your pull request. So that's all about today. That's all, and thank you for watching.